Hi guys, this is section 1.8 absolute values. It's a fairly short section, so hopefully shouldn't be too difficult. A lot of things that you probably have seen already, so we just kind of want to reinforce our knowledge about the absolute value equations and inequalities. All right, so let's get going. Now, if you look at the things to know, those are just definitions, and those are the definitions that we're going to refer back to throughout the problems. So just keep an eye on that. So let's go ahead and get started on the problems. Okay, the first problem we're going to work on is the absolute value of 5x minus 6 equal to 7, right? The way I remember to set this problem out like this goes like that. If I think about it, well, you know absolute value of 7 is 7. You know absolute value of negative 7 is also 7, right? So that means inside has to equal to 7 or negative 7. Okay? So that means I am going to use that idea and to help solve my question. My inside, in this case, is the 5x minus 6. So which means 5x minus 6 is either equal to 7 or 5x minus 6 equal negative 7. Okay? So once we realize that, the problem is pretty straightforward. The method is exactly the same. We're going to add 6 to both sides. Everybody add 6 to both sides. So which means I have 5x equal 13 or 5x equal negative 1. Okay, and from here, pretty straightforward. Everybody divide by 5. So I get either x equal 13 over 5 or x equal negative 1 over 5. And then we are done with this one. Okay, pretty straightforward. Once you get rid of the absolute value symbol, they just become two separate linear equations. Okay? Alright. So part B is going to be the 5 minus 2/3 x minus 9 equal to 8. Okay? Just like the last problem, let's go ahead and isolate the absolute value. So I'm going to add 9 to both sides first. And once I do that, I have 5 minus 2/3 x, which is equal to 17. Okay? And from here, just like that, we can finish the problem just like the last question. So the inside is either going to equal to 17 or the inside is going to equal to negative 17. And we can solve from here accordingly. I'm going to minus 5 on both sides, on everybody. So if I do that, I have a negative 2/3 x equal to 12. Or negative 2/3 x equal negative 22. Okay. And to finish this problem, I'm going to multiply both sides by the reciprocal. Right, so you multiply both sides by the reciprocals. This turned out pretty nice. All these crosses out. So you're left with x equal 12 times negative 3 halves, or x equal negative 22 times negative 3 halves. And let's simplify this further. 2 goes into 2 one time, goes into 12 6 times. 2 goes into 2 one time, goes into negative 22 negative 11 times. So this turned out to be 6 times negative 3, which is a negative 18. Or negative 11 times negative 3, which is a positive 33. So there are your two answers. Okay? Always isolate the absolute value by itself. and then we can use the properties to break it up. All right. All right, last one for this problem. Absolute value of 5x minus 6 equal absolute value of 7x plus 8. Okay, so this one is going to be pretty straightforward, same idea. Either 5x minus 6 is going to equal to 7x plus 8, or 5x minus 6 equal negative. Now, in this time, be careful. You need to put a parentheses around the 7x plus 8. Okay. All right. So, then we go and solve normally. I am going to add 6 to both sides. This problem, you end up getting 5x equals 7x plus 14. Right? Now, this question, I had to be extra careful. I probably should have distributed a negative 1 first. I probably should have distributed first to get rid of the parentheses. So let's do that now. I forgot to do that to begin with. So this is actually a negative 7x minus 8 plus 6, which means this is a negative 7x minus 2. Okay. All right. So from here, that's when things are going to be a little different. The equation on the left, the 5x equals 7x plus 14, I am going to minus 7x on both sides. So I get a 5x minus 7x is a negative 2x equal 14. Okay. Now, for the equation on the right, that's a minus 7x. So I had to plus 7x on both sides. So I get 12x equal negative 2. And from here, it's pretty straightforward. The equation on the left, divide both sides by negative 2. I get x equal negative 7. On the equation on the right, I had to divide by 12 on both sides. I get x equal negative 2 over 12, which is negative 1/6. And that will be your solution. Okay. All right. So it's pretty straightforward. Don't let that extra set of parentheses, the absolute value mess you up. Okay, that's not a deal breaker. All right. So now let's go ahead and start working on inequalities. And the first one we have is absolute value of 3x plus 2 less than 6. Okay, this one fits the format of absolute value of x is less than k. And this means x is between the k and negative k. Alright, so we're going to use the same setup. This is my k, and this is the stuff in the middle. Okay, so what I'm going to do is I'm just going to cut and paste. This is going to be 3x plus 2, which is less than 6, and which is greater than negative 6. Okay, and we did a problem like this before, right? If the variable is in the middle, that's pretty easy to solve. Minus 2, everybody. So I have a negative 8 less than 3x less than 4. Everybody divide by 3. So I have a negative 8 thirds less than x less than 4 thirds. And if you want to write this as an interval notation, this will be negative 8 thirds, parentheses, comma, 4 thirds. Okay? Alright. Part B. Absolute value of 5x minus 2 over 3 is less than equal to 4. Okay. Same idea. Isolate the absolute value. So I'm going to multiply by 3 on both sides. And if I do that, I have absolute value of 5x minus 2 is less than or equal to 12. Okay. Same setup as previous. 5x minus 2 is less than or equal to 12. And 5x minus 2 is greater than or equal to negative 12. And we can solve everybody at 2. I get negative 10 less than or equal to 5x is less than or equal to 14. And everybody divided by 5. I get negative 2 less than or equal to x less than or equal to 14 over 5. Or brackets, negative 2, comma, 14 over 5. Bracket. Okay. Alright. Number 3. Absolute value of 2x minus 7, that is less than negative 5. Okay, so this problem now, if you recognize what the answer is, great. If you don't, you'll eventually run into issues. So let's work this problem all the way out, and you'll see where the problem will come up. Okay, so this is 2x minus 7 less than negative 5 less than 5. Okay, and in this case, you're saying, hey, if I add 7 to both sides, I get 12 is less than 2x is less than 2. And if you divide everything by 2, you get 6 is less than x is less than 2. 6 is not less than 2. Therefore, no solution. Okay. So if you work all the way through, you're gonna run into this issue. 6 is not less than 2. Right? That just does not happen. Now, if you recognize this problem, you'll realize, hey, you know what? Absolute value is always positive. Right? Absolute value is always positive. There is no way a positive value that can be less than negative 5. I probably shouldn't use the word that today. There's no way a positive value can be less than negative 5. So therefore, no solution. Okay, so if you recognize right away, awesome. If you didn't recognize right away, you'll eventually run into an issue where there is a contradiction. Okay, so just keep an eye on that. Keep your eyes open. Double check. All right, part D. Part D, we have negative 1/3 absolute value of 3 plus x over 2. That is less than negative 2. Okay, first thing first, right? Remember, we always isolate the absolute value. So that means in this case, I need to get rid of this, the negative 1/3. Okay, so I'm going to multiply by negative 3 over 1 on both sides. And if I do that, these will cancel. So I get absolute value of 3 plus x over 2. Now, be very careful. When you're multiplying a negative number on both sides of inequalities, make sure you have to change the direction of the symbol. Okay, that symbol has to be changed every time you multiply or divide by a negative number. Okay, so now we have an absolute value of 3 plus x over 2 that is greater than 6. So if you look at number 1 things to know, there's a way to figure that out. This means either we have 3 plus x over 2 that is greater than 6, or 3 plus x over 2 that is less than negative 6. Okay, again, two separate questions, right? This breaks into two separate problems, and all we gotta do is just solve the problem individually, and then we'll be done. So minus 3 on both sides. I get x over 2 is greater than 3. And then from here, I can multiply both sides by 2. I get x is greater than 6. Or, the other part, minus 3 again. I get x over 2 is less than negative 9. So multiply both sides by 2. I get x is less than negative 18. Alright, so two different answers. Either we get negative infinity, comma, negative 18, union, or we get 6, comma, infinity symbol, and parentheses. So this will be our answer in interval notation. Okay, but be very careful, right? Don't just start switching stuff. First thing first, make sure you isolate the absolute value, put it on the left hand side of the inequality, and then go from there. Okay. Alright, last one. You got 9x minus 15 is greater than or equal to negative 20. This one's pretty straightforward. This is either 9x minus 15 is greater than or equal to negative 20, or 9x minus 15 is less than or equal to negative 20. Excuse me, positive 20, right, because sign changes. Okay, so if you solve it, you add 15 to both sides. You get 9x is greater than or equal to negative 5. Here on the right hand side, you get on the inequality on the right, you get 9x is less than or equal to 35. Divided by 9 on both sides by everybody. You get x is greater than or equal to negative 5 over 9, or x is less than or equal to 35 over 9. Now, this problem is easier to show on a number line. You get 35 over 9, which is somewhere over here. Negative 5 over 9 is somewhere on the left. X greater than or equal to negative 5 over 9 means you go to the right direction. X is less than or equal to 35 over 9, which means I start at 35 over 9 and I go to the left. Okay? And the key word here in this case is the or. Okay? This is not an and. Okay? This is not and, because if you remember, and means overlap. Okay? But we're looking for or. Or means I can either take the line on the top or I can take the line on the bottom. Okay? They're both okay. You can use either one of them. So which means in this case, guess what? Everything's covered, because from negative infinity up to 35 over 9 is covered. From negative 5 over 9 up to positive infinity is also covered. So in this case, solution is all real numbers. And the interval notation will be negative infinity to positive infinity. Okay? Slightly different. Alright? Now, again, if you are able to pick this out from the beginning, that's fine too. Same idea. Absolute value is always positive. This positive number is always greater than or equal to a negative number, which means you can pick any number you want. So we have all real numbers as solutions. All right, this section is done. It's short and sweet. Again, any questions, post on the forum, on the Blackboard. Send me an email, whsieh@grcc.edu, or call 616-234-4729. Okay, talk to you guys later. Bye.